So welcome to our lesson on cosine law. So we've already looked at sine law and how sine law is a ratio of lengths to the cosine of that angle. Let's look at this triangle for instance right now. We have an angle and we have two sides. What it's asking us to do is try to solve for C. What I'm going to do is write out all the parts of sine law with all three ratios being seen. So we get 26 over sine A. We get 12 over sine B, and we get C over sine 60. If we look at every part of these breakdowns of sine, you notice that every single one is missing a variable. Since they're all missing a variable and we don't have one that's fully complete, we can't solve it. At this point, our equation has stalled. We're missing parts, so we cannot solve this triangle using sine law. So we need to have another formula in order to find these out. This is where cosine law comes into account. So cosine law can be used to find an unknown side if we have two sides and a contained angle. So if you look up here, what I mean by contained angle, so I have two sides here. This angle is wedged between the sides that we know. Or if we have an unknown angle and all three sides are known. In an acute ABC triangle, cosine law relates the cosine of an angle to the three side lengths of the triangle. So here's the three different ways we can write it out. We have a squared equals b squared plus c squared minus 2bc cos A. And then b is virtually the same, except for we put where a was, b in those positions, and where b was, we put a back. Same with this. When we're looking at trying to find for an angle, we simply rearrange it. So if I rearrange this one that's related to the A value for trying to find cosine A or angle A, we do cosine A equals b squared plus c squared minus a squared over 2bc. And if you just pull out the A and say replace it with b, you would just where A is put b, and then where B was, you put A. So it's just rearranging the information we have. Let's try an example. So in this example here, which is our same problem from the beginning, we have two sides and a contained angle. What we're going to do is solve for C. So if we're looking at our cosine law, we've got c squared equals a squared plus b squared minus 2ab cos C. And this C is our contained angle. So what we're going to do is put in the information we know. A is 26 centimeters squared plus 12 squared for B minus 2 times 26 times 12 times cosine 60. We put that into our calculator. 26 squared gives us 676. 12 squared is 144. 2 times 26 times 12 times cosine 60 gives us 312. Still all equal to c squared. So at this point, what we want to do is use a square root of whatever this comes together to be, which is 508. And the square root of 508 gives us 22.5 centimeters. And that's how we would employ it in order to find a C value. Example 1 is the same sort of idea. We have 10 centimeters, 12 centimeters, and in between these two, we have a contained angle, and that is angle B. So what we do, if we're trying to find what B is, the nearest 10th unit, we set up our equation with it being B squared. So B squared equals A squared plus C squared minus 2AC cos B. We put in all of our information. So A is 12 squared plus 10 squared minus 2 bracket 12 bracket 10 cosine of 72. We start compiling all of our information. We get 144. This is all equals to b squared, by the way, plus 100 minus 74.1, that's a 4, 1641. What we get all with this, we're going to put into a square root, as we're square rooting to get b, which is 169 point, I kept 4 decimal places just to be as accurate as possible. And then I got 13 centimeters on the dot. So it's really just looking at what we have and then plugging in the information. For this time, in example 2, this is the case where we have 3 sides and we want to find an angle. So let's look at how we would do this. Where we're trying to find angle A, we want to make sure that our entire equation is equaling to A. So let's start off with that. Got A squared equals B squared plus C squared minus 2AB cos A. What we want to get by itself is the cos A. We want that to be isolated. So what I'm going to do is rearrange this a bit so we can have it isolated for cos A. What I'm going to do is bring this over to the other side to make it positive and bring our A squared over to this side and it becomes negative A squared. So that's our first step. So we get 2AB cos, maybe that's not A, that should be a C. My apologies, let me just fix that here. BC equals B squared plus C squared minus A squared. At this point, what we want to do is get this 2BC away from the cos A, so we can have cos A all by itself. So the next line, I'm going to have that divided out. So I got cos A equals B squared plus C squared minus A squared. And that's all over my apologies, 2BC. At this point, we have everything isolated. So now we can start subbing things in and then going and solving for what the angle A is. So let's start by subbing everything in. Our B is 8 centimeters, so 8 squared. Our C is 10 centimeters, so 10 squared. Our A is 7, so minus 7 squared. All over 2, 8, 10. We could, at this point, solve everything in here. That is great if we can make sure that it's all going to stay a nice even number. At these points, these will not have any decimals, so it's okay to go ahead and do that. This is still equaling to cos A. So I'm going to put this in my calculator. Where I put it. We get 64 plus 100 minus 49 all over 2 times 8 times 10, which is 160. So this top part becomes 49 over 160 equals cos A. Now at this point, this will be somewhat familiar. You've seen this before when we were doing our primary trigonometric ratios. If we want to find out what our A is, we need to take the inverse of cosine. So what we're going to do is go up here and we get A equals cosine inverse 49 over 160. We put that in our calculator, we're going to get an A value of 44 degrees. Example 3 is asking us to solve the entire triangle and wants us to round our answers to the nearest unit. So first, starting off here, what we notice is that we have two sides that contain an angle. When we see this pattern, we're always going to start off with the cosine law. After then, we can start using our sine law and then perhaps our properties of a triangle to go find our angles. So let's start off with finding what r is, this little r, because we have the contained angle between two sides. So we get r squared equals q squared plus p squared minus 2qp cosine r. Let's input what we have. So q is 15 squared plus 13 squared minus 2 times by 15 times by 13 times by cosine 70. So we get 225 plus 169. And when I put this in a calculator, what I got was approximately 133.3879. I kept 2 4 decimal points just to be as accurate as possible. At this point, I'm going to square root what I get when I deal with these numbers together, which gave me 206.612, which gives me, rounded to the nearest whole unit, 19. So r is 19. Sorry, not 19, 16. I wrote 16 and I said 19. R equals 16 centimeters. At this point, you'll notice that we have a full angle and length. So that means what we can do now is find one of these other angles using the sine law. I'm going to go and find q because I just feel like finding q. So sine q over side q equals sine r over side r. So that's my setup for the sine law. Right now I'm going to input what we know. We don't know what the angle q is, but we do know that side q is 15. We know that r is 70. That's our angle. And then over side r is 16. We rearrange so we can isolate sine q. That means multiplying 15 out. So we get 15 times by sine 70 over 16. At this point, we want to take the inverse of this entire thing. So sine inverse of this bracket. So q equals the sine inverse of 15 times by sine 70 over 16. When I put that in the calculator, I'm going to get a rounded to the nearest degree, 62 degrees for q. At this point, we now have two of our three angles, and we can use the principle that all interior angles of a triangle add up to 180. So we can say that angle P, I'm going to change colors just so you can see, angle P is equal to 180 minus angle Q minus angle R. 180 minus 62 minus 70 gives us 48. So angle P is 48 degrees. And through all those steps, we have found and solved our entire triangle. We now have all three interior angles and all three sides. We started off with the cosine law, then went to the sine law, and then went to our angles. So let's sum up what we know throughout this entire unit. For right-angled triangles, we can use the Pythagorean theorem and primary trig ratios. These can only be used when we have a right angle triangle. So the Pythagorean theorem and primary trig ratios. And by that, those are our SOHCAHTOAs. When we have non-right angle triangles, so acute triangles, we use sine law and cosine law. So how we break this up in a flowchart? What we're going to start off is look at our triangle. Is it a right angle triangle? If yes, you can either use SOHCAHTOA or your Pythagorean theorem. If no, you're going to either go with sine law or cosine law. Sine law can be used if you have angle, angle, side, or side, side, angle. Cosine law can be used if you have three sides or a side, two sides encompassing an angle. Those are the only ways you can do it. So this also breaks down the chart so you can see what we can use this for. Looking at these triangles, we can say what we can use these for. If we look at this first one here, we have a complete side and angle combo and an angle, unknown angle, and a known side across from it. If we have that, we can use our sine law. Looking at this next one, we have two sides that are encompassing an angle. Once we see that, we know that that is a cosine law. And last but not least, the last one we have, that is a right angle triangle. And we are looking for this x, and what we can use is either the Pythagorean theorem or primary trig ratios, but let's be honest, this will probably be easier if we just use the Pythagorean theorem. And it would also be far more accurate. And that's all for our cosine law.